Okay. Recording started. So what I usually do is ask for people to pick which questions I go over. So might have to give people another minute or two to log in if they're in the classroom. But do either of y'all have a question we can start on the exam review on Webwork? All right, here, let me at least share screen and talk about the first few. Till you find when you want me to work fully. Oh, 15. Okay. So this is the log graphing one. So you won't have to do the graphing part on the test. But let me grab a screenshot of this part. Come back over here. Flip the share back. So the only part that'll be on the test is just asking what's the domain of this function. So you're not actually going to have to sketch the graph or figure that out. So the domain we get by looking at the equation and then just taking whatever is inside the log and setting that greater than 0. So I would add the 4 over, and I have x is greater than 4. So on a number line, that's everything bigger than 4. So that gives us from 4 to infinity, and everything has parentheses for the domain. Now the vertical asymptote is whatever the boundary number is on the domain. So that's the vertical line at x equals 4. And our domain solving here is telling us which side of the asymptote we're graphing on. We're graphing on the right side. So if we were going to sketch the graph, the normal logarithm goes through the point 1, 0, and it shoots up like that. So this is like any unshifted, untransformed log graph looks like this. Now we've got two different shifts here. We've got a shift right and a shift up. So right 4 and up 1. So for a log graph, I like to take that 1, 0 point, and I'm going to move that right 4 and up 1. So that'll be going through the point 5, 1. Our asymptote moves over to the x equals 4, like we saw. But there is a negative sign in front of this graph. So this is going to be a vertical flip. It's going to swap positive y's and negative y's. So instead of it being an increasing graph, it's going to be a decreasing graph. So when we're picking which graph is it from the pictures, we're looking for the graph that clearly goes through the point 5, 1 and is decreasing. And that only matches one of the pictures. So problem 1 is our other domain question. Let me grab a screenshot. So the test is not going to ask you to do the domain of all of these. It's only going to ask the domain of one of them. It's going to ask the domain of the one that's the most complicated, so has the most going on, which is actually our square root function. But all of them feature the possibility of dividing by 0. So whatever is in the denominator, we set equal to 0 and solve, and then that is a domain restriction value. So like for g of x, that's a quadratic that we have to set equal to 0 and solve. Now this does factor, but if you're not comfortable factoring, you can also just use the quadratic formula and it'll give you the same two solutions. Two numbers that multiply to 14 are 7 and 2. And we have to make them both negative, so they add to -9. So this gives us 7, +7, and +2. But these are the values that make the denominator 0, so these are actually no values. I can equal anything except 2 and anything except 7. So when we do the number line, I'm going to put an open circle on 2 and an open circle on 7, and I shade in everything else. So this splits the number line into 3 regions. So our first region is from -infinity to 2. Our second region is from 2 to 7. And our third region is from 7 to infinity. And then we stick those together with u's. So if we have a quadratic on the bottom, that's how the domain ends up working out. But the one we're actually going to argue with on the test has a square root in it. So we're still going to set the bottom equal to 0. So we have x plus 2 equals 0. So we end up with x equals -2. But then I like to go back in and remind myself, this is the no value. So according to the denominator, x can be anything it wants except -2. Now the numerator has a square root involved. So square roots have a restriction that we can't square root negative numbers. So the inside of the square root is allowed to be greater than or equal to 0. And then I'd minus the 8 over, so I have x is greater than or equal to -8. So doing our number line for this one, All right, so -2 is an open circle. We're not allowed to equal that. -8 is a closed circle. But our inequality for the -8 says x can only be bigger than or equal to. So this is everything to the right. But when we get to -2, we're going to have to skip it. So this gives us two regions in our answer. The first region, I can't write, is from -8 to -2. And the second region is from -2 to infinity. Infinity always gets a parenthesis. The -2 here is getting parentheses because we're not including it, but the -8 gets a bracket. And then we just stick it together with a U. Now this question on the final is multiple choice. So you can actually, if you're thinking about it, you could probably just pick an answer without showing work, and that's okay. Like if you're confident in your answer, you don't have to show work, especially on multiple choice. If you pick the correct answer, you get full credit. But if you pick the wrong answer and you show me work that shows me like you were doing good work, it was making sense, you just didn't quite make it all the way there, you made a small error, then I'll still give you partial credit. So does that cover one? Like what to expect there? That good? So on the Webwork practice final, if there's only one question that's covering the thing, then it's going to be on the final. If there's two questions that's covering a topic, it'll be one of the two, or one part of one of the two, like some kind of weird amalgamation maybe. So there's 17 questions on the final. There's only 20 on the practice final. So most of those questions are going to be on there. So like question 2, you're going to have to do it. So this is our difference quotient. You're going to have to do this pretty early on in Cal 1 as well. But the bulk of this problem in calculus is still an algebra question. It's, do you understand the way function notation works, what this expression is asking you to figure out? So the g of x plus h so g itself is 3 minus thing squared. G of thing is 3 minus thing squared. But initially, the thing I am looking at is x plus h. So everywhere there was a thing spot, I put in x plus h. Now, this is an algebra expression that I'm going to work on expanding and getting rid of the parentheses. So we have 3 minus, and then x plus h squared is going to be x plus h times x plus h. So that's a FOIL situation, first outer inner last. So we'll have an x squared, an hx, and another hx, and then an h squared. So we have x squared plus 2hx, or xh, whichever order is fine, plus h squared. But this minus sign that was in front of the parentheses is in front of this whole entire x plus h thing squared. So we need this minus sign to distribute through these parentheses. And this is the part that's really easy to miss on the Webwork question. So g of x plus h is 3 minus x squared minus 2hx minus h squared. So my difference quotient now says take g of x plus h minus g of x and then divide that whole result by h. So my g of x plus h is this whole entire result I just got. So I'm going to substitute that in parentheses. Then my formula has a minus. And now I'm going to put g of x in. I have g of x up here. That is 3 minus x squared. I made another substitution, so I am using another set of parentheses. And then the formula had that whole result divided by h. Now on top, this minus g of x creates a distribution. It always creates a distribution here, but if you forget to write your parentheses, you won't see that the second term and any of the other terms need to have their signs changed. So this is another really easy place to make a mistake. Now the parentheses where I substituted in g of x plus h, there's nothing outside the parentheses there. So this one I can write without my parentheses now. But over here I'll have minus 3 and plus x squared. So now everything that's in g of x should cancel something from g of x plus h. So my result now is negative 2hx minus h squared, all divided by h. Now, since everything is being divided by h, I can factor that h out. Like, since everything on the top has an h to donate, that leaves me with leftovers of negative 2x minus h. And then those h's cancel. And our final result is negative 2x minus h. So I went from a crazy fraction with a whole lot of terms, and then this extra divided by h, canceled some terms, everything left over had an h I could factored out and canceled. I have my final result. You need to do all of those steps, simplify it down so the h cancels. And you got to watch out for the minus signs that they distribute through. So remember, anytime you make a substitution, you trade out one thing for another thing, put parentheses around the whole thing. Condom of mathematics, safe math. All right, is there another question you guys would like to see? Like any of the questions in the review? All right, then I'm going to grab question 5 next. Basically, if you guys don't give me a question to go over, I'm just going to pick some kind of at random, like questions that I wanted to make sure to talk about just to allay fears. So remember, the first problem on exam 2 was graphing some nonsense like this. So we had the first part of the question where we asked about what's the amplitude, what's the period, what's the midline, what's the phase shift. And then we had you sketch the graph. You do not have to sketch the graph on the final, but you do have to answer the 4 questions based on the equation. So our amplitude comes from our A value. So that is literally just 5. Whatever number is in front, there's your amplitude. Done. So there's our 4 values that we have to work with. Period comes from the B value, but the period is coming from the formula 2 pi over B. So that will be 2 pi divided by pi over 4. Now, dividing by a fraction is the same as multiplying by the reciprocal, so this is 2 pi times 4 over pi. The pi's cancel, and we get a nice period of 8. All right, our phase shift comes from the x minus 3 in the factored form. So x minus 3 looks like we'd be going to negative 3, but the inside lies. So we really are just going to positive 3. It's not going to ask about the max and the min on the final. So our phase shift is going to be 3 units right. And then it is going to ask about the midline, which is an equation, but the midline comes from the vertical shift. So this graph is going up 3. So that means the midline equation shifts from y equals 0 to y equals 3. Now, our max and our min value come from a combination of the midline and the amplitude. So we take our midline value and then we add or subtract the amplitude number. So in this case, that'll be 3 plus 5, so 8, and 3 minus 5, which is negative 2. So this one is not a multiple choice question because trying to write all 4 of these answers in a multiple choice is a giant headache, because then you're having to like snoop through each line and see which number changed, and it just gets real confusing. So this one is a free response. There's not really a lot of work to be shown here, like, maybe for the period, but like the amplitude, you just put a number down. And any of the free response, I'm doing partial credit the way I did on all the other exams, so it's not just all half or none, there's like in-betweens there as well. All right, so what's another one we can look at? All right, I got problem 6 then. This is a rational function that we're being asked to find the inverse. Now, the inverse was do the whole swap x and y and then solve for y. Now, when we solve for y, the other side of the equation can't have a y on it. So it's not just about getting a y by itself, but it has to be no other y's. All right, so let's write our equation. Y equals x over x plus 1. Now we're going to swap. So everywhere there's a y, I'm going to write an x. Everywhere there was an x, I'm going to write a y. So now I have x equals y over y plus 1. And now I'm just going to use my algebra skills to get y by itself. So first thing is, we don't solve algebraic fraction equations. Our first step is always get rid of the denominator. And I do that by multiplying both sides of the equation by the same thing, y plus 1. Now, since I am multiplying both entire sides, not just pieces, I have to wrap both sides in parentheses. And then what I am multiplying by is algebraically complex, so I also need to wrap that in parentheses. So the y plus 1 on the bottom cancels the y plus 1 that we chose to multiply by on the right side. So the right side has y by itself. The left side has y plus 1 times x. So this is going to need to distribute through. So I have xy plus x. And now I have y showing up in more than one spot. So it felt like, yes, my y is alone. Just kidding. No, it's not. So in order to get a singular y by itself, everything that has a y term comes to the same side. So I'm going to minus the xy from both sides. So now I have x by itself equals y minus xy. Now everything here has a y term, so I'm going to factor that common y out. So I have x equals y times, I'm going to put some parentheses. Now I completely pulled the y out, but I still need something here as a placeholder. So I give it a 1. So that way y times 1 would go back to y. If I don't put that 1 there, then that y term like disappears. And I end up with an expression that's not equal. And then from xy, the y is out front, so the leftover is the x. So y times the quantity 1 minus x. If I redistributed, y times 1 is y times x is xy with a minus in between. Those are equivalent. So I've done my factoring correctly. Now my goal is to keep y by itself. So I need to get rid of multiplying by something. And I do that by dividing. And I'm going to divide by the thing that I don't want to keep. Then once y is by itself, I could trade it out for f inverse of x. And then my answer is going to be x divided by 1 minus x. That's one way to get it. Now, if you did your algebra a little bit differently, you could also get negative x over x minus 1. That's algebraically equivalent. They're both correct because they're both communicating the same thing. So either of those answers is perfectly acceptable. So this is another this question, no, it's not free response. This question is actually multiple choice. But the answers are deceiving here. Like I was kind of a mean person when I wrote some of these multiple choice answers. Like some of the answers are, if you make a certain mistake, that answer will be one of the choices. So that's why I highly recommend showing your work. So that way, if you did fall for a mistake, you can still get partial credit. The big thing is when we do the inverse is not the reciprocal. So when you look at, let me zoom back in on the problem. We have x over x plus 1. The answer is not x plus 1 over x. But that answer will be an answer choice. So if you're not thinking or you didn't study this question very much, it's very easy to read that question and then like, oh yeah, that just means do the reciprocal. No, it doesn't. That negative 1 power is reserved for inverse notation. The only time it doesn't mean inverse is when it's just on an x. Then it means a negative power. Usually, though, instead of writing x to the negative 1, we go out of our way to write 1 over x. Just so we never use the negative 1 power unless it's an inverse. At least for problems that are presented to, like that are published or written, like as test questions. Now in calculus, we do often immediately translate 1 over x into x to the negative 1, and then we do calculus work on it. But the initial presentation, it's typically written 1 over x. All right, what's another question you guys would like to see? All right, then I'm grabbing problem 12. I'm kind of thinking through the problems I did already yesterday and trying to hit some of the ones I didn't do. So I'm not saying like the questions I'm skipping aren't good questions. They are good questions, but most of those I think I did do yesterday, or I did a similar one. So 12 here, they've given us pieces of a triangle and they asked us to figure out a third piece of the triangle. Or the, like, distance is a side length. Now, the picture I'm going to give you guys is not going to have the A, B, it's not going to have any letters on it. It's just going to be the numbers. You have to figure out what to call those letters. So some of you guys are still struggling with labeling the triangle appropriately. So let me go ahead and draw the triangle. All right, so we're told we have a satellite. I don't know what a satellite looks like, so sure. The satellite can calculate the distance. It sends out a ping and calculates the distance to things it's looking at. So it calculates the distance to the first city as 397 kilometers. It pings another city and it gets 363 kilometers. And it can measure the angular distance between the two that it sweeps, and it measures this as 2.9 degrees. And it wants to know, find the distance between the two cities. So that's our unknown. All right, so when I have my triangle with the numbers and the angle filled in there, like I see lots of information, I need to label things to use an appropriate formula. Now, the two formulas we have for this are those two formulas, the law of sines and the law of cosines. In either of those two cases, though, we have pairs of things that go together. So alpha with side A, beta with side B, gamma with side C. Now, my law of cosines only has one angle in it, angle gamma. So when I have a triangle with only one angle given, I call that angle gamma. Now, once I've decided that is gamma, the side opposite gamma must be side C then. So we are solving for side C. We know gamma, so I know like this one, and then this is my unknown. Now my other two things are the other two side lengths, the non-opposite sides, the two adjacent sides to gamma. So those are A and B. And it doesn't matter which one you call A versus which one you call B. So I usually just go with the left one or the upper one as A, and then the other one is B. That means my angle opposite side A, this is angle alpha. My angle opposite B is angle beta. So when I'm looking at what do I know side A. I don't know alpha. I know side B, but I don't know beta. So when I look at my law of sines, I know three things, but it's a single thing in each fraction. So I can't use law of sines to solve for anything in this triangle initially. But when I'm looking for side C, my law of cosines formula, I know A, I know B, and I know gamma. I can fill in my numbers on this formula. So that's what we're going to use, law of cosines. So we have c squared equals, A is 397 squared plus B is 363 squared minus 2 times 397 times 363 times the cosine of 2.9 degrees. So that whole ridiculous mess we can type on the calculator. Now, on the final exam, some of the problems, like you'll barely touch the calculator, but some problems, especially once you're about to type a trig symbol, a trig function, you need to check yourself. Should I be in degree mode or radians mode? This one, it's 2.9 degrees, so we need to be in degree mode. All right. So, yep, I'm in degree mode. All right, now I'm going to type that whole entire thing. So 397 squared plus 363 squared minus 2 times 397 times 363 times the cosine of 2.9. And this spits out 1,525.1094, blah, blah, blah. And that will be one of the answer choices, because this one is multiple choice. But that is not the correct answer. That is what c squared equals. That number is way too big for our triangle. We've got 397 and 363. Those two together can't bridge a gap of 1,500. Because 397 plus 363 is only 700 something, like 760. But we had c squared is equal to that. So if I cancel out my square by square rooting, or raising this to the 0.5 power, I get 39.0526, blah, blah, blah. Our angle between these two sides was very small. It was 2.9 degrees. So the side opposite 2.9 degrees should be very small in comparison to the other two. So about 40 kilometers instead of 360 or 400 kilometers, that is more reasonable. So I'd type that many decimal places. On the test, you're going to be picking from a list, but I think they round it to 2 places. Now, I did try to make these problems, like if your calculator accidentally is in radians mode, I tried not to put that answer on the test. But if you make like several mistakes in your calculations and you're in radians mode, it might end up being close to an answer on the test. But if you just like did everything correct, but just had your calculator in the wrong mode, I tried to make sure that wasn't an answer, at least for this problem. Like I calculated it like 6 different ways to pick out my answers. Because this question in particular, it's very easy to have your calculator in the wrong mode and not realize it. So if you do the calculation and you're like, this isn't the answer, double check your mode. Like if you don't see the answer in the answer choices. All right, last one, because we've only got a few minutes left. This is a log properties one. So I am not going to give you the log properties written on the front of the test on the formula sheet in the back. You do have to remember these. Now I'm just going to do the second one because the numbers there are uglier. So when I have the natural log of, or the log of a quotient, I can change this into the natural log of the top result minus the natural log of the entire bottom result. So there's my first quotient rule log property. Now inside here, I have a product. My log or natural log of a product turns this into two logs with a sum. But I am about to make a substitution. I am about to trade out this single log for more than one log. So I need to put parentheses here, safe math. So I'm about to write natural log of b to the negative ninth plus natural log of c to the eighth. So I make sure that whole thing has parentheses around it. Because that minus sign is going to have to apply to both of those terms. Now, I like to go ahead and distribute the minus sign now. And that's just changing the numbers in front. So now I'll have the natural log of a to the negative 3 minus the natural log of b to the negative 9 minus the natural log of c to the 8th. And when you get really used to log properties, it is actually totally reasonable to go from the initial line straight to this line. A to the negative 3 is on top, so it has a positive log. B to the negative ninth is on the bottom, so it has a negative log. C to the eighth is on the bottom, so it has a negative log. Like that's another way to reason through to get to this line of work. All right, now our last property is our power down rule. So it's going to bring all of our powers down in front. So this is going to be a negative 3 in front of the natural log of a. Then minus negative 9 natural log of b minus 8 natural log of c. And then we just clean up this minus and negative part, but you could technically leave it there. So negative 3 natural log of a plus 9 natural log of b minus 8 natural log of c. And I have some people who actually jump from this line straight to that bottom line. When they bring the negative down, they're like, oh yeah, that's plus now. That's totally fine. So it's very easy to miss the distribution of the minus sign for everything on the bottom. But if you think about what this middle line means based on the structure of the original problem, like everything that was on the bottom of the fraction should end up with a negative log before we bring down any powers. Now, since some of those powers have negatives, like that's going to mess with our final result signs, but that's because Another way to work this problem is I could have moved stuff around in the fraction first. So the b to the -9 comes up top. It would be +9 up there. The a to the -3rd would move to the bottom. It'd become a to the +3rd on the bottom. And then I could use my log properties on that result. I'll end up with the same final answer, but the process will be a little bit different. All right, so we've still got class on Monday, and then our final is on Friday. No, Monday. Sorry. Monday, 11 a.m. to 12:50 p.m. My 10 a.m. Monday, Wednesday, Friday class has their final on Monday, May 11th, a week from Monday at 11 a.m. in our normal classroom, McKinney 20206 by the elevators. All right, let me hit the stop recording.